Okay, welcome to the end of the chapter, section 7.7. After the last section's rather lengthy video, this one I think is naturally to be broken up into a couple of 10-minute segments, okay? What this last section's about is a good place to put it. I think it's smart because we're talking about radicals, okay? We're about to go into chapter 8, which is talking about quadratic equations. And as you saw in the last video, sometimes you cannot factor it, so you need to take the quadratic formula, run it through its paces, and you end up with answers with radicals in them. But here's the thing, you can end up with answers that have radicals, square roots of negatives. Square root of negative, you can't do that. Well, now we can, because we're going to go through this section, and it deals with what they call complex numbers, okay? And complex numbers basically just the idea of going to so-called the imaginary numbers, okay, open up a whole realm of solutions in engineering and science. So it's like this super number system, of which the number system we're familiar with is just a subset of it, okay? So the topics are going to be the definition of them, and in this video I'll do that, and plus we'll talk about how to add and subtract them, which is really actually kind of easy. The main thing you want to get out of this is the story that, hey, we're trying to do stuff like, trying to solve something like, oh, gee, I want to solve an equation that says x squared plus 4 is 0. Well, it doesn't factor because that's not a difference of squares. But if you go, well, if I isolate the x squared, I got a negative 4, right? Okay. And we're going to do this actually in section 8.1. It's called completing the square to solve things. But in the meantime, we're a little ahead, but that's okay. The next thing is, well, what I'm trying to figure out is a number that when I square it, I get negative 4. Well, there's no number that does that, right? I mean, if I take 2 times 2, I get 4. If I take negative 2 times negative 2, I still get 4. Yeah, I can go negative 2 times 2 is equal to negative 4, but it's not the square of a number. Those are two different numbers. So I'm trying to fill these boxes, and I'm having a hard time with it. In fact, if you just go, instead of that, why don't we just try to go, something times something is just negative 1. Okay, what is that? Here comes the invention. You ready? How about we just say I, as an imaginary number, times I, imaginary number, i.e., that is to say, I squared equals negative 1. And that's our definition right there. That's our definition. Two ways of writing it. I squared is negative 1, or I itself is the square root of negative 1. And that's all you have to know in this section to survive complex numbers, so to speak. Okay? So that's what I was doing here. Trying to solve x squared equals negative 1, we're confronted with this question, which number squared equals minus 1? Well, it had to be invented. And I is the so-called, it's the original imaginary number. Okay? If we go back to x squared is equal to negative 4, we can start making more progress with that one too. So that would be something like, well, x is equal to, let's see, I think I could say something like the square root of negative 4 maybe. Okay, actually it's plus minus, and that also is in the next chapter. See, I'm getting ahead of ourselves a little bit, but I just want you to see where this is going. I'm trying to solve this equation. Well, what do we do with that? I'll show you. Remember roots and radicals? There's two numbers that I can think of multiplied in here. Minus 1 times 4. Okay? And from our chapter, we can split this apart. Yeah? And what is the new definition for who's the new guy in town? What is this? That's I. And I think we all know the square root of 4 is 2. So you know what our answer is? 2 times I. And that's also imaginary. It's twice I. Okay, fine. That's great. Pretty cool stuff. All right. So that's the start of it. let's see what else is going on here. Yeah, that's just the arithmetic of it. I want to go a little bit farther with this though, just a little bit. What if we had something like a problem that said like, oh, I've got 3x minus 2 squared is some negative, okay? Let's make it, this is actually something from 8.1, but let's say it's negative 25. That means that 3x minus 2 by its lonesome is the square root of negative 25. I don't know if you're following that or not. The square, if this guy squared is negative 25, then he must be the square root of negative 25. Watch what happens now. Okay, so we've got 3x minus 2 is equal to, okay, we're going to do the same thing here. We're going to go square root of negative 1 times 25. I might skip a step here and say, you know what we have? 5i. You okay with that? And if we're trying to solve for x, we have 3x. Here's the weird thing. We're going to go plus 2 and end up with 3x is equal to, where do I put the 2? If I go to the tail end of it here, if I go plus 2 over here like a lot of people do, this is gone, right? Then you're right, but would you combine those together? I would say no, because they're like unlike terms. Now typically we write it this way, 2 plus 5i, and if you're really focused on that 3 to get rid of it, okay, I will. There we go. And we actually get x is 2/3 plus 5/3 times I. And this is the beginning. This is the story. Complex numbers right? Complex numbers, they have what they call a real part in front, and over here plus, with the I there, an imaginary part. And so what I'm pointing out to you, in this case, what we have is a 2/3, which is the real part, and a 5/3 I, which is the imaginary part. Now, I'm not going to go into the complex plane and how you plot them. That could be another course for you. But I did want to show that to you, okay? And, oh, and by the way, you can have a number that's like up here, which is what they call a purely imaginary number. But you can see it's part of the same number system because there is a real part, 0 plus, and then the imaginary part. So this guy, purely imaginary, the real part is 0. And guess what? If you take just an ordinary number like 22, a real number, well, that can be looked at as 22 plus 0i. So what I'm saying is that real numbers and purely imaginary numbers belong to this family of complex numbers. Isn't that weird? So the real number system we know is actually a subset or a subspace, if you will, of the complex numbers. Pretty cool. So the last thing for this video, because I'm trying to shorten it, is how to add these things together. Okay, and yeah, it's kind of an easy process, as you're going to see here before we get there. So I'm just looking ahead to see how much we got to do. So I went a little too far, so maybe I'm getting too wordy, but it really is important to kind of appreciate what we're doing here. Okay, so problems look like this. I have an example up here, but to save time, you can read that. But what we're going to do is we're going to simplify this again. We're just going to go, this is 2 times the square root of minus 1 times 4, right? Which is 2. Okay, now what do we do with that guy? We square rooted 4 to get 2, but then it's a negative, so it's 2i. So that first term is 4i. Go ahead and do the second one. Plus the square root of negative 1 times 81. Plus 9i. Plus 9i. When you're dealing with complex numbers, you really don't have these radicals. This is actually a contrivance of this book and all algebra books. They're bridging us from what we know to this kind of notation here. Okay, how do you add stuff together? What do you do in this case? You add like terms. That's kind of a story that's down here. Way down here, when you're adding stuff, you combine like terms. Okay, oops. Word. Let it get settled. Let it get settled. It's settled. Okay. That's so strange. It's floating. So what do we do? You guessed it. 13i. Okay. Let's do this other one. So what we're doing is we're adding, or it could be subtracting, by combining like terms again. Boy, do we do that a lot in algebra. You bet we do. That's math. But really what you're doing is you're adding the real parts with the real parts and the imaginary parts with the imaginary parts. All right, let's go a little bit quicker with this one. This first number is 3. Can you do the square root of a 10? A square root of 100? It is 10. But it's not negative 10. It's not minus 10i. It is 10i. Okay? So plus 10i. And then the next number is 12 what? Plus 3i. Good job. 3 and 12, 15. 10 and 3 plus 13i. You've done it. Amazing, isn't it? And you know, it gets even easier. I mean, incredibly easy as it goes. These are called complex numbers. I guess I didn't practice this one. I already went crazy with complex numbers, so we can skip this section. But yeah, you're combining the real part and you're combining the imaginary part when you're adding this stuff together. When I wrote this up, I didn't think I'd go crazy like I did. Okay, so half page before we end this video. Here's a problem example. This time it's not written in the funky square root of a negative. It's just basically, combining like terms. So this section here is really going to be easy for you guys, I think, because a problem might say something like here, add or subtract. And so it could be something like 5 minus 2i and add to it negative 3 minus 4i. And you just go, okay, here we go solving it. 5 minus 2i plus, okay, so plus a negative, so minus 3 minus 4i. And we're getting 5, doing the real part, 5 minus 3 is 2, and then minus 6i. If it's subtract, see how easy this is? If it's subtract, 7 plus 22i, or make it negative, I guess, for fun. Okay. And then minus 4 minus 10i. The only thing is, as usual, is you distribute the negative when you subtract. So we end up with a minus 4 plus 10i, right? You with me? And so 7 minus 4 is 3, and then we have a minus 12i. Okay, we'll come back on the next video and tackle the multiply and divide, okay? See you there.